Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
All righty, The Naked Scientist. Good morning to you, Chris. Are you well?
Yeah, I'm good, thanks. Good morning, Reedy.
Excellent. Thank you very much for joining us. Okay, let's start with this SMS from Timan. It came last week. And Timan wants to know, does alcohol affect women physiologically the same way, women's physiology the same way as it does men?
I think the answer is that basically yes, although with some differences. The inebriating or making you drunk effect of alcohol is because alcohol increases the activity of a family of nerve cells in the brain which use the nerve transmitter or signal chemical GABA, gamma-aminobutyric acid. And this is an inhibitory nerve signaling chemical. So if you increase its activity, which is what alcohol effectively does, it makes cells more sensitive to the effects of GABA, then it makes other cells in the brain become less active. And that's why alcohol is a sedative. It has an anesthetic-like effect. And this will be true whether you are male or female. In terms of other effects around the body, men tend to be bigger than women, and therefore they have more space, more volume in which to put the alcohol. So alcohol at any dose will affect a woman maybe a bit more than a man, assuming she hasn't built up a big tolerance. Men also have a bigger liver than women, on average, and therefore men will have a higher capacity for breaking down or detoxifying alcohol than women, because the liver is where there's an enzyme called alcohol or ethanol dehydrogenase, and this enzyme breaks down alcohol and turns it into initially something called ethanal and then vinegar, effectively, which you can then wash away, a non-toxic substance instead. So in the grand scheme of things, both people are going to be affected the same way. At a more specific level, because men are bigger than women, they will have more places to put the alcohol, and therefore there will be fewer focal effects, and there could be fewer health effects for any given dose of alcohol. But in general, the effects are both the same for both. Okay,
and here's another SMS. Sillo wants to know, are there any other animals besides humans that menstruate?
Well, animals do have a menstrual loss of blood. People who may see their dog occasionally do this if they've got a female dog, and that's called being in season. But I think humans are effectively the only animals that have a monthly regular menstrual cycle, but I would need to check that just to make sure whether other animals that are close relatives of ours, like chimpanzees, may do something similar. Many animals actually do a sort of thing called being a reflex ovulator. Rodents do this, and what that means is that when they have sex, they ovulate, which means that then they can immediately fall pregnant. They don't have to wait for the right time of the month.
As they're having sex?
The same process as to when they actually have sex triggers them to release an egg, so that they can time the arrival of sperm with the release of an egg, so that they have a high prospect of falling pregnant. And this is why animals like mice and rabbits, I think, are so successful at increasing their populations very fast. They don't have to wait for the right time of the month.
And speaking of fertility and ovulation and all of that, I received an email from, she's actually doing the Cape Argus, the Argus cycle on Sunday. How many kilometers is it? 106 kilometers, I think. And good luck to you, Sandra, good luck. But she sent an email 2 weeks ago wanting to know, is there a relationship between infertility and excessive exercise? I'm interested in that.
There is. And in fact, quite a famous actress, Zola Budd, I think, had one of the other manifestations of excessive exercise in a woman to compete at very high standards demanded of things like Olympic events. You end up having to push your body fat down to a very low level. And when a woman reaches a body fat mass of less than 15% of her entire body weight, then her menstrual cycle stops. There is a signal that goes from fat tissue to the brain's hypothalamus, which is the part of the brain that controls when you have a menstrual cycle. And so the brain is continuously aware of how much body fat you're carrying. In order to protect the woman's body, because if you were to fall pregnant when you are starving hungry, this would be very bad for you and bad for the baby, then the menstrual cycle can be switched off in this way. So many female athletes will actually become amenorrheic. If they become too thin, then their menstrual cycle stops for a while, and this means that they are effectively infertile because they are not ovulating. A consequence of not ovulating is that estrogen levels also fall, and estrogen looks after your bones and keeps them strong. So if you have low estrogen, you also tend to lose bone mass as well, and you're at higher risk of getting osteoporosis. So women under the magic 15% of fat mass are at higher risk of osteoporosis. And there was quite an interesting paper, it was a while ago now, but it was in the British Medical Journal, and they showed a whole raft of the mannequins that you see in the shop window advertising the latest fashions for women. And the headline said, could these mannequins menstruate? And by working out to have that body shape, how much fat those women, if they were real, would be carrying, the answer is it would be way under the magic 15% number, and none of those mannequins that are supposed to be the paragon of health and fertility would actually be capable of having a baby, because none of them would actually have a menstrual cycle. So being more than 15% fat mass in a female is good for you, because it maintains a healthy menstrual cycle and makes sure your bones stay strong and you stay fertile.
Okay. We're taking your calls for the Naked Scientist. Anything that you want to ask him on 021 446 0567 011 883 0702. Chris, I've observed something. There are a lot of birds in my garden, and I find in the afternoons especially, they'd all gather around the pool and drink from the pool. And I wonder, yeah. And
what have you got in the pool?
I don't know. And I watch them and I'm thinking, what's going to happen? Because there are all sorts of chemicals and chlorine, and that can't be good for them.
Probably not, no. Have they changed colour? Have they bleached out and gone white? Because chlorine, of course, damages colours as well, doesn't it?
And they don't drink for long. It's like a few sips and then they go and decide that this is not good enough. And then they're back again a few minutes later or the next day.
Maybe they're different birds. Maybe they learn their lesson once. You could try peeing in the pool. That might be nice. Maybe you do that already, I don't know. Some people do. But chlorine isn't very good for you. It's okay on the outside of your body because it doesn't actually end up inside your body at appreciable concentrations, and it's much worse for bacteria because they're swimming around in it all the time and it kills them. If we were to ingest that level of chlorine all the time, it would be bad for us. There are other chemicals in pool water as well. There are flocculating chemicals like aluminiums and various aluminium salts. There are fungicides to stop the pool going green. So there are lots of other things in there, and they usually have copper in them. They're not good for you either. So it's not a good idea to drink pool water. I suspect the birds don't realise this, though, not having a degree in medicine or whatever. So if they're thirsty and they think, well, there's a convenient patch of water, they're going to fly down and drink from it. Because birds are pretty good at recognising what water looks like.
All right. Let's go to Nick in Bryanston. Hi there, Nick.
Hi, good morning.
Good morning.
I'd like to know, is it safe for the old wives' tale or not to have a bath or a shower while there's lightning and things? Because I've never heard of anybody being killed in a shower or bath by lightning.
Okay, I think we've had this one before.
No, neither have I, Nick. Yeah? I don't think there's any risk over and above if you were just standing in your house. If your house gets hit by lightning, catches fire and falls down, and you're in the shower, you might argue that actually you'd be better off because you'd be wet and the fire would go out. But no, I'm not aware of any particular risk of being in the shower or the bath. Going into a lake is a different matter, because if you're swimming around in especially a freshwater lake, then if that lake gets hit by lightning and the area that gets hit is near where you are, your body is a much more concentrated bag of salty water than the water in the lake is. And salty water conducts electricity much better than fresh water does, because fresh water is only very slightly ionised, and therefore it doesn't really conduct electricity very well. So if there is a lightning strike near to where you are in the pool or the pond, then the lightning will see your body as the human equivalent of a lightning conductor or a lightning rod, and a lot of the current, as it dissipates, will dissipate through you, and this could be very bad. And you do see spots of the sea where fish have actually died because a pool or a bit of the sea has been hit. The sea is less unsafe because it's very salty, in fact much more salty than you are. But fresh water is a risk, so don't go swimming in ponds and outdoor pools and things in a thunderstorm.
Okay, thank you very much, Nick. Give us a call on 021-446-0567, 011-883-0702. I have an email here from somebody who wishes to remain anonymous. She says that she suffered from anorexia in her teens and has tried to keep a healthy weight in the last 6 years. I imagine that she's in her 20s. Please ask the Naked Scientist, what are the long-term effects of this? I'm too frightened to even start eating normally because everyone has told me that starving myself for so long, my metabolism has slowed down, and anything I eat will be stored as fat. It feels like I'm fighting a losing battle because I want to get well and to eat, but cannot do so for fear of retaining all that weight, that fat.
I'm very sorry to hear this. And this really explains very clearly, the way that's written, the major problem that people who suffer with anorexia have, and that is that they really struggle to let themselves feel that they can eat. And we know that this is actually regarded as a psychiatric problem. It is an eating disorder. It's a disease in the same way that depression is a disease, and luckily it can be treated with help and people can recover. But it is the one disease which has the highest rate, if it's not handled well and people don't get help, of people dying. It's far worse than almost any of the other diseases that you can get in terms of your likelihood of having a bad outcome if you don't get help. I think this person has obviously taken it seriously, recognises there's a problem, has good insight by the sound of it into what the problem is. I would strongly urge that person to go and talk to somebody, because the evidence is that your body is very good at adapting minute by minute, hour by hour and day by day to what you have available to you in terms of calories. And if you eat a little bit more this week, then you can always eat a little bit less next week to make up for it. Just because you eat a little bit more this week, you won't have a problem next week if you need to lose a bit of weight. And it sounds to me like this person's problem is not losing weight, it's actually making sure you put a healthy weight on, because if you don't eat properly, then all of your tissues are continuously in a state of stress because they're trying to get the micronutrients and the building blocks they need to make the things that keep the cells healthy. If they don't get them, the cells don't work properly, and as a result, the tissue actually becomes damaged in the long term, and it's deleterious in the long term. So it's very important to eat properly, and it's much easier to lose weight if you get a little bit too big than it is actually to rescue someone who's got very bad anorexia. So I would definitely go and see somebody and see if you can get a bit of help to come up with a diet plan that you know is not going to make you fat, but is going to give you what you need to eat.
Okay. Thank you very much, and good luck to you, Anonymous. Luke, please stay on the line. I'm going to take your call right after this.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Luke, thank you for your patience in Century City. Good morning.
Hi there, guys. I have a quick question. Well, actually, it's a two-part question. My son yesterday had a fever fit. It seemed when he came out of nowhere. 1 minute he was fine, playing, happy. The next minute he was literally seizing up on us. Once the seizure had finished, which was about a minute and a half, we took him to the hospital, where they did a lumbar puncture to test for meningitis and encephalitis, which both came back negative. My question being, are there any pre-warning signs that we could have sort of seen to be aware that he was about to seize? And second of all, what other likely causes could have caused the spike in temperature?
Hello, Luke. How old is your child? I would think he's probably quite little.
He's 15 months.
Yeah. This is called a febrile convulsion. It's very common. And for some reason, we don't know exactly why, but when little kids get an infection or something that drives their temperature up very high, they are at risk of having a febrile convulsion. Thankfully, this is not the same as getting epilepsy in the sense that individuals who have febrile convulsions are not epileptic. They may be at a slightly higher risk of getting epilepsy later, but they're certainly not destined to become epileptic, and they're not also guaranteed to have another one of these febrile convulsions. Thankfully, after they're over, there do not appear to be any long-term serious health consequences, apart from the fact that you may end up having to take them to the hospital to get checked out for reassurance, and you're aware of the fact that it can happen again. But making sure that the temperature doesn't go up in too much of a sustained way is probably the best way of preventing it, because there are no other warnings that it might happen, and therefore giving temperature-lowering drugs like paediatric doses of paracetamol or Nurofen, ibuprofen, can be very effective and keep the temperature down, and then your risk of this happening again is really low. But I can reassure you that if there's no sequelae, in other words, no consequences visible after this one, it's probably a febrile convulsion, and probably everything will be fine, and you'll never see it happen again.
Oh, okay. In fact, that was my next question, Chris. That does the fact that it's happened this once mean that it's it is common and he's got nothing to worry about? But were it to happen again in a short space of time, and again, would that be indicative then of a problem?
Well, it's certainly indicative that maybe something should be checked out. A pattern of things emerging, in other words, something changing in that way, is always more worthy of being investigated. And out of the blue one-off, you never set store by a one-off. We would always seek to corroborate whether something was actually a sustained change or not. So a one-off like that, I would certainly say, probably reassure you it won't happen again. But there is a small risk that it might. Obviously, you can never say never in medicine, but I think probably I can reassure you it'll be okay.
John in Lenstown, hi.
Hello, good morning. Hello, Chris. I just wanted to know about photocatalysis, and whether it is true that titanium dioxide can break down polluting VOCs through photocatalytic activity. Have you heard about that?
Hello, John. This is the whole basis of self-cleaning glass. And there's a number of people who have come up with this as a technique, including one fairly major glass company in the UK called Pilkington. And what they have done is to fabricate a glass surface with these nanoparticles of titanium dioxide on them. And the titanium dioxide effectively gets energized by high energy wavelengths of UV in light. And it uses that energy pushes that energy into other molecules like carbon molecules that form muck on windows and things like the VOCs, and it can break them down because it basically puts the energy into them, breaks bonds in the molecules and rearranges bonds in the molecules and breaks them down, and then when it rains you can easily wash off the resulting debris or it just blows away. So self-cleaning glass works on this basis, and also titanium dioxide is being used as a very effective gatherer of energy for a range of other photovoltaic things and systems and chemical cells as well now. People I was talking to in Australia have got a way of collecting energy from sunlight using titanium dioxide and then driving an electrical cell to generate hydrogen with it. So yes, it's quite a good material for that and is undergoing a lot of research in this area.
And we move from John to Robin in Douglasdale. Richard, I see your call. I'm coming to you next. Robin, hi.
Morning, Chris and Reedy. My question revolves around gallstones. I have a friend who's just been diagnosed, and the question is, what exactly are they? Why do they develop? Is it unhealthy lifestyle or eating? How do you prevent them? And why is it so important to have them removed immediately?
Hello, Robin. In medicine, we were taught that the reason you get gallstones is because of all the Fs. You're not going to like this. It's fat, female, fertile. I don't know how many of those you fit, or your friend fits. But the bottom line is that gallstones form out of bile in the gallbladder. The gallbladder sits just underneath the liver, and the liver makes bile, and bile is one of the things that you use to emulsify and break down fats in your intestine. So bile is a mixture of bile salts and cholesterol and also stuff that your liver chucks away in the course of breaking down, including hemoglobin. And this fat-rich mixture is squirted into your small intestine down the bile duct at a place called the ampulla of Vata, and it goes into your duodenum, and where it sees fat in what you eat, the bile helps to break up the fat into what are called micelles. In other words, you turn big globules of fat into very small globules of fat, and this makes them easier for enzymes to break them down. The problem is that this very fat-rich mixture in the gallbladder can, if you change the recipe or composition of it very slightly, start to form small stones, because some of the things that are in there are only just able to dissolve. And it's a bit like if you make a pot of water and you start adding a spoonful of salt and stir it around, the salt will dissolve. If you add another spoonful of salt, the salt will dissolve. If you keep doing that, eventually you get to what's called a supersaturated state where you cannot make any more salt dissolve. And if you start adding more, you see it dropping out at the bottom. This is a bit like bile. Some of the things in there, such as cholesterol, and the vast majority of the stones that form are actually made of cholesterol. These are stones that are forming because they cannot dissolve any more cholesterol in the bile you're making. And some people seem to be stone formers. They have a tendency to form these stones. And something called nucleation probably happens. Once you've got one little stone or crystal forming, it's easier to make big ones. The vast majority of gallstones cause no problem whatsoever. But as long as they stay in the gallbladder, they're not an issue. It's when they actually get moving, and sometimes they can either jam in the neck of the gallbladder, or they can go down the duct, which goes through the pancreas and then out into the intestine. They can jam that duct, and then they can cause problems. It can be very painful. You can get biliary colic. You get a pain, which usually is provoked by eating, and especially if you eat fatty food, because there's a signal that says when you eat fatty food, I need more bile, put more bile down. And the way to remedy this is you wait till the symptoms resolve, and then they can take the gallbladder away. And if you take the gallbladder away, there's nowhere for the stones to form, and this doesn't appear to be harmful to a person, but it does appear to resolve their symptoms for them. More catastrophically, if the gallstone gets stuck somewhere, it can cause more severe problems. You can get infections and that kind of thing, but thankfully, that's more rare. So why is it more often in women? Because women have estrogen, and there's something about the way that estrogen is handled that it provokes the formation of stones in bile more than in blokes.
Oh, okay. Good luck to your friend, Robin. Sounds very unpleasant. Richard in Boysons.
Hi there.
Hi.
I wanted to know why aquatic mammals, particularly porpoises and whales, have horizontal tails and all fish have vertical tails.
Hello, Richard. It's a very good observation you've made, and the reason is that aquatic animals like dolphins and porpoises and whales, they are mammals that evolved on land and then went back into the sea. And in fact, the closest relative of a whale, and Charles Darwin highlighted this when he said a hippopotamus moves almost like a whale. So in other words, these are animals that were land evolved and then had to re-evolve the ability to move in the ocean. In order to develop that tail, they had to turn their two back legs into a tail, and they did that by, instead of separating the two legs, they merged their two legs into one long tail. Wow. And we have a hip joint, which means that our legs go backwards and forwards, so as a result, the tail of those evolved mammals goes upwards and downwards, whereas a fish never actually had to evolve legs. In fact, fish evolved to have legs and come out of the sea, so they evolved to have a side-to-side motion, which they've stuck with. And that's why sharks have a tail which is upright and goes side to side.
Very interesting. Thank you very much, Richard, for that question. And we have an answer to the lightning question, Chris. Ern says you must not shower when lightning is around because you won't have time to get dressed if the house is struck.
Good call. I like that one.
Bye, Chris. Chat to you next week.
Take care, Rudy. Bye-bye.
Bye.